Hello and welcome back to another episode of Math with Stone. Today I'm going to be working through an assignment that had a lot of different things that were going on involving exponentials and square roots and stuff. I'm going to be doing the even ones, but some of the odd ones that I assigned for my students right now. Let's get into it. So if you have a problem like number 2, where it's asking you to square root the 225, and then the a to the 16th and the b to the 36, you would square root 225 if a calculator needed. Go ahead if you need it. Square root of 225 is 15. But then divide 16 by the invisible 2 to get a to the 8th and b to the 18th. Plus or minus only because they had a plus or minus in the beginning of the problem there. Okay? So that is all you have to do for square roots of these problems. If you have a 4th root or an 8th root, like we have on number 8, I'm going to be jumping around a little bit to make it better for our learning. If it's an 8th root, instead of taking and dividing by 2, you would divide by 8. So this would be equal to x to the 2nd, y to the 1st as the final answer there. So it's that simple, but sometimes you encounter problems that are just a little bit more difficult. For instance, number 7 is a little more difficult because you have this x to the 3rd to the 12th. Well, you can actually just do the x to the 3rd to the 12th first. You don't have to. You can do it first if you wanted to, and write the 4th root of 16x to the 32nd power, because you'd have to multiply that 3 and that 12. And when you do that, now you can do the 4th root of 16. Well, the 4th root of 16 is not the square root. It is not 16 divided by 4 either. It is what multiplies by itself 4 times to equal 16. In this first section, for the most part, simplified with our calculator, and this one is no different. It is 2. But then we would have to divide 36 by 4 to get 9. So 2x to the 9th power. All right? I'm going to do one more from this section, and that is number 9, because number 9 is, in fact, different. Okay, the first thing I would do is I know what the 4th root of 81 is, and a lot of people also did this in my classes. The 4th root of 81 is 3. And then I would just deal with the 4th root of what I have remaining. Well, the 4th root of what I have remaining is 4 to the 3rd. 4 to the 3rd is 64. 12, because I would have 4 times 3 making x to the 12th power. And then y to the 3rd, z to the 3rd. All right? So now we have the 4th root of this stuff, and the only real thing we're going to be able to do is do the x to the 12th part. But the y to the 3rd and z to the 3rd, they're dead because 4 does not go into 3 or 3. They can't go into that. But I can break down my 64 into a lot. It'd be 2 and 32, 2 and 16, 2 and 8, and then 2 and 4. So it's a lot. It breaks down into a lot. And I'm looking for 4 of a kind here. I have 1, 2, 3, 4 2s. That number is going to go on the outside and multiply with what's already there. Well, what's already there is a 3. So if I multiply 2 and 3 together, I get 6. And I'm also going to deal with my variables now. The 4th root of x to the 12th power is going to be divided x to the 3rd. But nothing else simplified. So I have to keep everything else underneath the square root symbol, the 4th root technically. And what is left is this 4, because it did not break down and did not have 4 of a kind, and the y to the 3rd and the z to the 3rd. So this is the official answer for that one. So that one was difficult. Moving on, if we have to write the expression in radical form, this one is an easier section by far. If it is an exponent, they want you to write it as a radical. So this is going to be the 7th root of 4 squared. You could also write that as the 7th root of 16. You could also write that as the 7th root of 4 quantity squared. Any of those 3 answers are correct and are fine. If the problem is presenting you with something that is a radical to begin with, then you would need to turn it into an exponential form. So whatever one you got to do the opposite. So this is going to be 5 to the 1/3 power, x to the 1/3 power, y to the 2/3 power. Or you could say 5xy squared, quantity to the 1/3 power. I don't know if I like that one more. They both have their pros and cons, to say the least. Okay? Moving right along, if we have to evaluate an expression. Evaluating an expression, I would highly recommend just typing it in your calculator. But if you want to do it by hand, for instance, if I wanted to do number 23 by hand, I would have to recognize first that this is 1 over 16 to the 3 over 2 power, because a negative exponent means I have to put it to the bottom of the fraction. And then from here, I would have to do the square root of 16 to the 3rd power, because the 2 goes on the outside and the 3 goes on the inside. And I don't know what 16 to the 3rd power is, but I do know what the square root of 16 is, and that is 4. And I could figure out what 4 to the 3rd power is also without a calculator, which is 64, because I just know what 4 to the 3rd power is. If you needed to use a calculator for any of these, you could, and they're all the same. So that's the only thing that I'm going to do from that section before we move on to the next chunk of questions, which is what to do when you have situations like this. So here, in this situation, if you have these two that are sitting right next to each other, I'm going to zoom in a little bit because they're really small, you would have to add your exponents. So if we added 4 over 9 with 1 over 4, you would be able to get 4 over 9 plus 1 over 4, 4 over 9, ooh boy, plus 1 over 4. In most situations, you will have a calculator that will add that fraction for you. And you would end up with 25 over 36 as the final answer there for a to the 25 over 36. Excuse me. Number 30, negative exponent. If you have a negative exponent, you need to put it to the bottom of the fraction. Y to the 4/5 power would be on the bottom. And then you have to think, I can't keep a fractioned exponent on the bottom of the fraction, so I would have to multiply by 1 over 5 and multiply by 1 over 5 to be able to complete the whole thing, because if I have 4, I need 1 more. So I had 4 of them, I needed 1 more. That would leave y to the 1/5 and y to the 5 over 5 on the bottom, which you don't need to write 5 over 5. You could just write y to the 1st power, or not bother writing anything at all, because 5 over 5 is just 1. Y to the 1st power is just y. Next chunk, simplifying. Here, we would have a situation on number 32 where you might want to consider doing the inside first, but you don't have to. If we did the inside first, we'd have x times 2 to the 6th, and then x to the 6th. And that actually doesn't really help, but it could. If we have 2 to the 6th and you wanted to evaluate what 2 to the 6 is, you could. And then you could square root that. But you could also think about it like, well, wait a minute. If I have these written as exponents, I can't do 2 doesn't go into 1, but 2 does go into 6 3 times. And 2 does go into 6 3 times. And you could deal with it like that. And that would mean that we would have 8x to the 3rd, square root of x left over. That's one way to deal with it. The other way would be to actually do x to the 7th, 2 to the 6th is 64, and the square root of 64 is 8. There is way more than one method to do some of these. All right, so do not feel compelled to only use the one method. Moving along. Let's see, I want to do one of these for us that are on the left side. Let's do the 64 one, 33. If we break down the 64, because it does not simplify completely, we end up with a lot of 2's. And we're looking for 4 of a kind because it is the 4th root of 64. So if we do that, we would have a 2 on the outside and a 4th root of 4 left over. I left a blank here so that I would have room for my variables if they have like a place to go. So the 4th root of x to the 3rd can't do anything because 4 does not go into 3. But 4 does go into 6. 4 goes into 6 one time with 2 left over. So we're going to have an x to the third, and then that y squared, because 4 goes into 6, one time, remainder of 2. The 2 on the outside came from the 4 2's that I circled, and this 4 is the 4 that was left over there. That is my final answer for this one. All right. We got one more from this chunk that I'm going to do, and that is number 43. If you have a situation like this, you would have to multiply your exponents, and if we multiply those two together, we'd have 3 over 12 from 3/4 times 1/3. You would multiply the top and get 3. 3 times 1 is 3. 4 times 3 is 12. But 3 over 12 does simplify down to 1/4. Okay? Moving along, we got one more section left, I believe. One more tiny section left. I am going to do the evens because there's not a lot here. And I don't want to do 48, but I'm still going to do it. Still going to do it. I might do it last, though, because that does look like a harder one. Here on 50, a little easier. If you have a situation where you have a fraction over another fraction, you need to subtract them and give it to the bigger side. Well, the difference between 4 over 5 and 1/2, if we subtract them, 4 over 5, delete, oh my gosh, 4 over 5 in my calculator minus 1 over 2 is 3 over 10. So we have z to the 3 over 10 power. Done. On 52, if we have AB over the square root of C, we would need to multiply by the square root of C and the square root of C, because if I have 1 and I have a square root, I need 2. And if I do that, I would have AB square root of C all over C. Also done. Not bad. Now, if it were a cube root, we would need to multiply by 2 of those. So on 53, I would actually have to multiply by the cube root of Z squared and the cube root of Z squared, just so you're all aware. All right, 48, last one, and I'm done. We got f to the negative 1/4. We got f to the negative third. We need to flip-flop both of those for our first step. So this is going to be f to the 1/3 on the top. The bottom is going to be 4f to the 1/2. That 1/2 is not negative, so it stays positive. And then f to the 1/4 on the bottom, because it would continue to be positive once you move it. This 1/2 and 1/4 I need to combine. So I am going to run out of room, but I'm going to combine them. I'm going to get f to the 1/3. 4f, if I add 1/2 and 1/4, I end up with 3 over 4. And then, just like number 50, I have to find the difference between these two. But the big difference here is that 3 over 4 is way bigger than 1 over 3. So when I get the difference, I'm going to have to put it to the bottom of the fraction. So that would mean that this would be f to the, what we got to find the difference between 3/4, 3 over 4, minus 1 over 3, because 1 over 3 is smaller. I would actually subtract that one. I get 5 over 12. So this is going to be 4f to the 5 over 12 on the bottom of the fraction and 1 on the top. Out of room. We're not allowed to keep that 5 over 12 on the bottom of the fraction because it is it's a radical. So we have to multiply by what we are missing. Well, we are missing, in order to get to 12, 7 more. So we need to multiply by 7/12 and 7/12. And that would leave me with f to the 7/12 over 4f to the 12 over 12, which is 1. So we would have 12 over 12 when we add 5 and 7, which is f to the first power, and our final answer, and our final question that I plan on doing. That's going to do it for this one. I hope everybody has a great day. I will see y'all later. Bye.